In this topic, we're supposed to distinguish between independent or mutually exclusive events given conditional probability information. Independence it means that two things can happen together. Mutually exclusive means two things cannot happen to one another. You know, like independence, an example of that would be the event that I choose my blue shirt today and the event that it rains today. Assuming I haven't looked at the weather forecast, because maybe it'd say, oh, maybe you're picking blue because it's raining or something. Okay, so I haven't looked at the weather. I have no influences on me. I just, 2 weeks ago, I planned out my outfit. I said I'm going to wear a blue shirt. Okay, and then it rains. They're not affecting each other. They're independent. So that means they could happen together. Mutually exclusive would be like the probability that I wear my blue shirt today and the probability that I wear my red shirt today. I'm only going to wear one shirt. I'm a one shirt type of person. I don't wear two shirts at the same time, right? So those two events, the probability that I wear a blue shirt and the probability that I wear a red shirt, those are mutually exclusive. They cannot happen at the same time. So if two events are independent, then the probability of both of them is the probability of the first one times the probability of the second one on their own. If they're mutually exclusive, this is in depth, the name of my new band. I'm just kidding. Probability of A and B is 0 if they are mutually exclusive. So exclusive. Me and my fiance. Wait, that doesn't make exclusive, not mutual. I guess mutually exclusive still works there too. Okay, anyway, if two events cannot happen together, they're mutually exclusive, and the probability of both of them is 0. Okay, so we're given some information. We're asked to say whether events A and B are mutually exclusive, independent, both, or neither. So we got to decide about independence and mutually exclusiveness. Okay, if they are independent, then you should be able to take the two probabilities and multiply them. So probability of A is 1 out of 12. The probability, actually we don't have the probability of B. We have the probability of A given B, which is found by taking the probability of A and B and dividing by the probability of B. That's the formula for conditional events, one event given another. So we can find the probability of event B because we know this, the probability of event A given B, that's 1 out of 12. The probability of A and B, they tell us that's 1 out of 16. And now this is a little algebra equation to solve for the probability of event B. You can multiply the probability of event B to both sides. That gets it out of the denominator. And then multiply 12 to both sides to get the probability of event B is 12 out of 16, which when you simplify is 3 out of 4. Okay. So now we can check to see if they're independent. Right? So if you plug in the probability of B that we just found, and if we multiply these, and if it makes 1 out of 16, boom, they're independent because it matches the formula. We get 3 out of 12 times 4, 48, right? And that's 48 divided by 3. If you divide the top and the bottom by 3 to simplify, you get 1 out of 16. So they are independent, we just found out. Okay? So we're going to pick this one. Because once you've decided something is independent, it can't be mutually exclusive, right? Mutually exclusive events are two events, unless one event has a probability of 0. Okay, that's the only condition. The probability of A and B, it's 1 out of 16. So that means that the probability of A and B is not 0. It's 1 out of 16, so it can't be mutually exclusive. We found out it is independent, so that doesn't meet this criteria. A and B are both independent, but they are not mutually exclusive, so that's why we're not choosing that option. Yeah, so check out this one here. That's why I hesitated on that last video. If the probability of A and B is like 1 out of 16, it means that they can't be mutually exclusive. But if the probability of one event is 0, then it's possible they could be independent and mutually exclusive. Because check out the formulas. If you plug in probability of A equals 0, probability of B equals 0.25, then the probability of A times probability of B, that makes 0, just like it's supposed to for the independence criteria, right? Follows this formula here. But then it also follows this formula here. The probability of A and B are 0, so this one is both independent and mutually exclusive.